So this video is on something called chromatography. It's important. I think you did something on it earlier in the year. It was in chapter number 1, but I really didn't get a chance to truly discuss it. And it can show up in the AP exam, so I think it's worthy of discussion now, especially since we just did a bunch of videos on IMFs. So this was done with a Sharpie. So they put what they did was they have water down here at the bottom of the beaker, and they put a little dot right here of Sharpie. And what happens is the water slowly goes up, and as it moves up, the chemicals that are inside the dot of Sharpie marker, which is clearly at least 3 chemicals in there, a yellow pigment, a red pigment, and a blue pigment, separate. And they separate based upon their relative attraction. This is what chromatography. There's lots of types of chromatography. There's liquid chromatography. There's high pressure liquid chromatography. There's thin plate chromatography. There's gas chromatography. There's ion exchange. I mean, there's like literally 50 types of chromatography, and they're all based upon one simple concept. The concept is that there is a mobile phase and there's a stationary phase. And the movement of the particles up this piece of paper or through what is this the paper, in this case the paper ironically is the, or fittingly, is the stationary phase because the paper is not moving. The mobile phase in this case would be the water. But what you use for the stationary phase is a lot of times it's beads. Sometimes it's beads with antibodies on it. There's all sorts of different things they can use for the stationary non-moving stuff. The mobile phase can be liquid or any other solvent. So you could use an organic solvent like an alcohol like ethanol or chloroform. Chloroform. There's all sorts of organic liquids, which means they're not water. And a lot of them are non-polar. So you can use different types of solvents. But if you use water, okay, what this tells you about the relative attraction of the substance that's moving for the stationary phase versus the mobile phase. In this diagram of chromatography, what you can see is this blue splotch of ink over here has moved the furthest. Okay, and this right here is the edge or the front of where the water went up to. So the water went up to there from here, and it traveled a certain distance. The blue stuff almost traveled as far as the water did. The red stuff didn't travel nearly as far, and the yellow stuff traveled even a shorter distance. And what this says is that you have to think of it as almost like a tug of war. See, the yellow stuff wouldn't stick to the paper unless it was attracted to the paper, nor would the red or the blue ink. All those things are attracted to the paper, but some of them are more attracted to the water. And so it's almost like they hitch a ride on the water molecules and move with them. And that's the basis of the separation. Which of the 3 colors had a greater attraction for the mobile phase that moved with the water? Well, that was the blue stuff. So the blue is more attracted to the H2O. And that probably means the blue stuff is probably polar. Maybe it can hydrogen bond. It probably has more similarities to the water than the other molecules. The other molecules probably are more attracted to the yellow stuff, all right, to the paper. I mean, like the yellow is more attracted to the paper because it's more attracted to the stationary phase. And therefore, it didn't move with the water because it was sticking to the paper. Now, the idea, they often give what's called an RF value, and I don't know how important this is, but it shows up on one of the exams I gave you. So let's just make sure we're clear on this. In chromatography, you're separating out a mixture. This is a homogeneous mixture, which you are going to separate out based upon the relative attractions of the substances that you're trying to separate in the mixture for the mobile phase and the stationary phase. Whichever thing travels the furthest is more attracted to the mobile phase and has more in common with it. So if the mobile phase is water, then the blue stuff in this particular picture, or wherever traveled to water, is probably capable of hydrogen bonding with the water molecules and might be more alike in structure to the water than it is to the paper. The yellow stuff, which is more attracted to the stationary phase, is more like the paper. Now, you could use a different solvent. You could use an organic solvent that is nonpolar. If, let's say, you use, a nonpolar solvent instead, then and whatever travels furthest in the nonpolar solvent would probably be also a nonpolar molecule. Now, they do one calculation. It's called RF value. And I'm going to do this really quickly. So I'm not even going to do proper numbers. So the RF value is basically the distance that it's basically how far the mobile phase traveled over how far one substance traveled. Right? So essentially, you could measure from here to here, let's say from this line right here and to this line right here, and let's say that the mobile phase traveled, let's say 10 centimeters. All right, and now we find the center of the blue spot like right there, right? And so we put like 8.5 on the top, and that would be the RF value. And 8.5 over 10 is like 0.85. So the RF value for that for the blue stuff would be 0.85. The red stuff travel much shorter distance. Let's say it travels 7 centimeters. So for the RF value for the red stuff would be 7 centimeters over 10. So its RF value would be 0.7 and so on and so forth. So that's the RF value. That's all you really need to know about chromatography. Relative attraction for mobile versus stationary phase, which if it travels very far, it's probably like the mobile phase. If it doesn't travel very far, it's probably very chemically similar to the stationary phase. And RF value is how far the substance traveled over the total distance that the mobile phase traveled. Thank you.